Good morning. Myself is Dr. Gray Rathore. I am going to present the topic on network analysis. Topic is network theorem, tangent analysis, and two-port network. Network theorem. Network theorem are rules and formulas in electrical engineering that simplify the analysis of complex circuit by reducing them to more manageable components. Key theorem include superposition theorem, Thevenin's theorem, Norton's theorem, maximum power theorem, and Miller's theorem, substitution theorem, etc. What is Thevenin's theorem? Thevenin's theorem simplify any electrical circuit into a single equivalent circuit with one voltage source in series with single resistor. This equivalent circuit behaves identically to the original complex circuit at its two terminals, making it easier to analyze, especially when the load is changed. You can see here any complex network is converted into single voltage source along with series resistance RTH, that is Thevenin's impedance. And second, Norton's theorem. Norton's theorem states that any linear circuit can be simplified to an equivalent circuit consisting of a single current source and parallel resistance, that is Thevenin's impedance. Norton's theorem states that any linear electrical circuit can be simplified into a single ideal current source in parallel with single resistor. You can see in the figure here Norton's current is with Norton's impedance are shown. Next, superposition theorem. Superposition theorem is a method for analyzing linear circuit with multiple sources while considering each source individually. It states that the total voltage or current at any point in the circuit is the algebraic sum of the voltages and currents produced by each independent source acting alone with all other sources turned off. You can see in the figure there is two voltage source E1 and E2 are given. Here we consider one sources at a time. One source is considered as a active and second sources is considered as a passive. To turn off a source and voltage is replaced by a short circuit and a current source is replaced by an open circuit. Next, maximum power theorem. The maximum power transfer theorem is defined as the condition in which the power supplied to a load is maximum when the load resistance equals to the source resistance applicable in a linear circuit with one variable load. Millimeter's theorem. Millimeter's theorem simplifies a parallel network of voltage source and their internal resistance into a single equivalent voltage source in series with single equivalent resistance. It is useful for finding the voltage across a load connected in parallel to multiple sources by reducing the circuit to a simpler form. This theorem can be applied to both DC and AC network by using conductance. Reciprocity theorem. The reciprocity theorem is an electrical engineering principle stating that for linear passive single source circuit, the ratio of its response to an excitation remains the same when the location of the excitation and response are interchanged. In simpler terms, if a voltage source in one branch produces a current in another branch, moving the voltage source to the second branch will result in a exact same current flowing back through the first branch. Next, compensation theorem. The compensation theorem gives information about the change in the network. The compensation theorem works on the basic concept of Ohm's law. Compensation theorem states that the resistance of any network can be replaced by a voltage source having the same voltage as the voltage drop across. Now, transient analysis. Transient analysis is the study of system response during temporary period of change, such as when a circuit is switched on or off until it settles into a new steady state. This analysis involves examining how voltage and current behaves over time in response to change in the input, particularly in system with energy storage elements like capacitor and inductor. It uses methods like solving differential equation and Laplace to predict the system time domain behavior. There are two methods, classical methods and Laplace method for solving transient analysis. This is the best example of resistance capacitance transient analysis. When switch is moved from 1 to 2 and switch moved from 2 to 1 in the RC circuit. So here Q is equal to CB 1 by e की power minus t RC. It is a response of charge. You can see here current dq upon dt, that is CB minus 1 upon RC e की power minus t upon RC. So in this figure, this is the current response with time. Transfer function. The transfer function is usually defined for two-port network. For networks shown in figure, the following transfer function can be. Here, two-port network. So there are two port 1, port 2. At port 1, voltage V1 is applied and port 2, voltage V2 is applied. A transfer function is usually defined for a two-port network for the network shown in figure. The transfer function is the Laplace transform of output time function to the Laplace transform of input time function. So there is a four parameters: voltage gain, current gain, transfer impedance, or transfer admittance. It means output quantity upon input quantity. Output quantity may be voltage or current, and input quantity may be voltage or current. Now, two-port network parameter. There are number of alternative sets of parameters that can be used to describe a linear two-port network. That usual sets are respectively called Z, Y, H, and G, and ABCD parameter is described individually below. They are usually expressed in matrix notation. So V1, V2 is equal to Z11, Z12, Z21, Z22. These are the Z matrix or Z parameter. So Z11 is equal to V1 upon I1. That is input impedance. For reciprocal network, Z12 is equal to Z21. For symmetrical network, Z11 is equal to Z22. And for lossless network, all the Z minimum are purely imaginary. These are the Y parameter shown in figure. These are H parameter shown in, and it is a equivalent circuit of H parameter. Next is ABCD parameter. These are G parameter. G parameter. These are G parameter equations. I1 and V2 in terms of V1 and I2. Thank you.